So here we're going to identify the hybridization state of each of the carbons. So let's begin with carbon 1. Carbon 1 is attached to 3 hydrogens and another carbon. So it has 4 bonds. Each of those is a sigma bond. So we have 4 bonds, 4 sigma bonds. To make those 4 bonds, it hybridized its s orbital with 3 of its p orbitals to make 4 equivalent bonds. So carbon 1 is an sp3 hybridization. Any carbon that is bonded to 4 atoms will have sp3 hybridization. So carbon 2 is also sp3. And carbon 5 is sp3. Each of those is bonded to 4 different atoms. So let's look at carbon 3. Carbon 3 is bonded to 3 atoms. It's bonded with a sigma bond to the carbon below. It's bonded with a sigma bond to the hydrogen that's slightly above, and it has a sigma bond to the carbon beside it, and it has a pi bond to the carbon beside it. So we have 3 sigma bonds and 1 pi bond. The 3 sigma bonds are created from an sp2 hybridization. So the atom has taken its s orbital and combined it with 2 of its p orbitals. However, it's left 1 of its p orbitals unhybridized to participate in this pi bond. So carbon 3 is sp2 has sp2 hybridization. Carbon 4 is the same, sp2. Whenever you have a double bond like this, just one double bond, and 3 atoms are bonded, you'll get an sp2 hybridization. So let's look at carbon 6, and carbon 7 is the same. Carbon 6 has a sigma bond to the carbon that's behind it, and it also has a sigma bond to the carbon that's in front of it. So we have 2 sigma bonds, and we also have 2 pi bonds. This is a pi bond, and there are 2 pi bonds there. All right, so in order to form the 2 sigma bonds, the atom hybridized its s orbital with just 1 of its p orbitals to have sp hybridization. It left 2 p orbitals, the py and maybe the pz, unhybridized to participate in this pi bond. And C7 is the same as C6. So whenever you see a triple bond, you're looking at sp hybridization.